Alright, we are ready to begin our next lesson. Today's learning goal is that students will be able to convert and compare customary units of capacity. And we're going to do this the same way that we did customary units of length, and we're going to be using dimensional analysis in order to solve these types of problems. We're going to talk about some new terminology here. The first term we're going to talk about is capacity. Capacity is simply the quantity or how much space an object takes up. And the customary units of capacity that we use, we have quite a few. The teaspoon is the smallest, and then the tablespoon, fluid ounces, then cups, pints, quarts, and gallons, which you may be more familiar with. In order to use our dimensional analysis, we need to know what our conversion factors are. And so I've included a list of the conversion factors. Please copy these down, keep them in your notebook, make sure that you have them available. After each of the names, I've included the abbreviations just in case you get confused as to what the problem's asking for if they're using abbreviations, and sometimes they do. So let's move on to our sample problems. Our first sample problem is that we're going to convert 3 fluid ounces to some number of teaspoons. Okay, so I've gone ahead, I've written the problem down. 3 fluid ounces equal to some number of teaspoons. I've also gone ahead and written the conversion factor that we're going to use. 1 fluid ounce is equal to 6 teaspoons. So we're going to write our division line. We're going to fill in what they give us, 3 fluid ounces, and draw a line here to separate it. We know that whichever unit that we have on the top of the first step needs to go on the bottom of the second step. So we look at our conversion factor. Where's fluid ounces? Well, it's right here. And so we're going to use fluid ounces. So we're going to put the 1 fluid ounce on the bottom, and then we're going to put what's left over, the 6 teaspoons, on the top. Now we cancel units. We can cancel fluid ounces and fluid ounces. We can also cancel the 1 out because anything multiplied by 1 is going to be itself. And we multiply across the top, multiply across the bottom if we need to. So we have 3 times 6 is 18. We have teaspoons left on the top, and then underneath, well, everything's been canceled out, so we don't have to calculate that. So 3 fluid ounces is equal to 18 teaspoons. Our next sample problem is we're going to convert 32 fluid ounces to some number of quarts. Alright, so we've written down the second problem. 32 fluid ounces is equal to some number of quarts. I've also written down several conversion factors, and this is one of the benefits of using dimensional analysis, is that if you do not have the exact conversion factor, you can use combinations of conversion factors in order to help you calculate and solve that answer. So again, we start off the same way. We write our division line, and we start off with 32 fluid ounces. Typically, we'd look for a relationship between ounces and quarts, but we don't have one. Matter of fact, the only thing that we have with fluid ounces is this relationship where it says 1 cup is equal to 8 fluid ounces. So we're going to start with that one, and then we're going to move through and add other ones as we need. So if we have fluid ounces on the top of the first section, we need to have fluid ounces on the bottom of the second section. So we have 8 fluid ounces goes on the bottom. And that's equal to 1 cup. We're not at quarts yet, so we're going to draw another vertical line, and then we're going to continue on with our division line. We don't have a relationship that goes from cups to quarts, but we do have one that relates cups to pints, so we're going to use that one next. In the second section, we have cups on the top, so that means we need to have cups on the bottom of the third section. Well, it shows that we have 2 cups right here, so we're going to write that 2 cups on the bottom of the third section, and then the pints is going to go on the top. Well, we're not at quarts yet, and so we're going to continue on with our dimensional analysis. Now, do we have a relationship that goes from pints to quarts? Well, yes, we do. We have this one that says that 1 quart is equal to 2 pints. Since we have pints on the top of the third section, we need to have pints on the bottom of the fourth section. So we're going to put the 2 pints from this conversion factor on the bottom. And the 1 quart goes on the top. Well, now that we've ended with what we're looking for, we wanted quarts, we ended with quarts. Now we're ready to cancel units. So we have fluid ounces on the top and fluid ounces on the bottom. We have cups on the top, we have cups on the bottom. We have pints on the top and we have pints on the bottom. And now all we're left with for our units is quarts, which is exactly what we're looking for. We can also cross out the ones because we know 1 times anything is going to be itself. So now we multiply across the top. 32 times, well, that's all there is 32. So we're going to put the 32 on the bottom. We're going to multiply across the bottom. So we have 8 times 2, which is 16. 16 times 2 is 32. So we have 32 on the bottom. And so that's going to equal 1 quart. So 32 fluid ounces is equal to 1 quart. Our third problem is that we have 4 quarts and 2 pints is equal to some number of fluid ounces. So I've written the problem out here. 4 quarts plus and 2 pints is equal to some number of fluid ounces. In this case, because we have 2 units, we're actually going to have to work out 2 problems. We're going to have to solve for the quarts first and then the fluid ounces. So we're going to start off with the first one. At 4 quarts. We're going to use our same relationships that we used in problem 2, so instead of writing them over again, we're just going to refer to these up here. We don't have anything that goes from quarts to fluid ounces, but we do have something that goes from quarts to pints. So we're going to use that one. Since we have quarts on the top of this on the first section, we need to have quarts on the bottom of the second section. And so the number we're going to use is 1 quart. And that's equal to 2 pints. Well, we're looking for fluid ounces, so we're not done. We don't have anything that goes from pints to fluid ounces, so we need to use this one that goes from pints to cups. Since we have pints on the top of this section, we need to have 1 pint on the bottom of this section. The 1 pint comes from here, and then we're going to use the 2 cups from our conversion factor. Now we do have a relationship that goes from cups to fluid ounces. Right here, 1 cup is equal to 8 fluid ounces, and so we're going to use that. Because we have cups on the bottom, because we have cups on the top of the third section, we need to have cups on the bottom of the fourth section. And 1 cup equals 8 fluid ounces. So we wanted fluid ounces, we're ending in fluid ounces so we can stop. We can cancel units. So the quarts cancel, the pints cancel, the cups cancel. We're left with fluid ounces. We can also get rid of the ones. And then we need to multiply across the top. Multiply across the bottom if we need to. In this case, we won't need to because everything's already been canceled out. So we have 4 times 2 is 8. 8 times 2 is 16. And then 16 times 8, well, I can't do that one in my head, so I'm going to have to write that over here. 16 times 8 is 128. So we have 128 on the top, and then we're going to keep our units fluid ounces. And then there's nothing on the bottom. So 4 quarts is equal to 128 fluid ounces. But we're not done yet because we also have to take care of these 2 pints. And so we need to find out what that is. So we're going to do that again with a second dimensional analysis. So we're going to use 2 pints. Again, we're going to use our relationships. We don't have anything that goes from pints to fluid ounces, so we go pints to cups. Pints on the top means we have pints on the bottom. And then we need to go cups to fluid ounces. We have that relationship up here. Cups on the top means cups on the bottom of the next step. And that equals 8 fluid ounces. Cancel units. Pints cancel pints. Cups cancel cups. We're left with fluid ounces. Now we multiply across the top. Oh, let's cancel our ones. Multiply across the top. 2 times 2 is 4. 4 times 8 is 32. So we have 32 fluid ounces on the top. And everything's canceled on the bottom, so we don't have to do that. So now we have 128 fluid ounces, which is the 4 quarts. We have 32 fluid ounces, which is the pints. So we need to add those together. So 8 plus 2 is 0. Carry the 1. 1 plus 2 plus 3 is 6. And then bring down the 1. So that would be 160 fluid ounces. Alright, in our last sample problems, we're going to convert 132 cups to gallons, and then we're also going to convert it into gallons and cups. Alright, so I've gone ahead and written the problem down. 32 cups is equal to some number of gallons. We have 2 answers we're looking for. One is going to be gallons by itself, and the other one is going to be gallons and cups. So the first thing we do is we write down the problem. We have 132 cups. We don't have a conversion factor that goes from cups to gallons, so we're going to use the steps that we did before. We know that there are 2 cups and 1 pint. We know that there are 2 pints and 1 quart. And I've gone ahead and written over here that there are 4 quarts in 1 gallon. And we notice that whatever we have on the top in the first section, we have on the bottom of the next section. So cups and cups, pints and pints, quarts and quarts. So now we can cancel. The cups cancel the cups, pints cancel the pints, quarts cancel the quarts. Get rid of the ones, and we're left with gallons. So 132, there's nothing to multiply by, so that's the numerator. And that's gallons, because the gallons are left. And then we have 2 times 2 is 4. 4 times 4 is 16. So now we have a division problem, 132 divided by 16. Well, I don't know the answer to that, so I'm going to go ahead and solve for that. Alright, so 16, I think 16 goes into 132 about 8 times. 8 times 6 is 48. 8 times 1 is 8, plus 4 is 12. Subtract and borrow. So 12 minus 8 is 4, 2 minus 2 is 0, 1 minus 1 is 0, and so we're left with the remainder of 4. So if we just want gallons, then what we're going to do is we're going to take our remainder and make it the numerator. We're going to take our divisor and make it the denominator. And so our answer is 8 4/16, which we can reduce to equal, we'll write it down here, 8 1/4. Gallons. Alright, so 132 cups is 8 gallons and 1/4 of a gallon. The second problem that we did asked for how many gallons and cups. Well, you'll remember that the remainder is actually how many cups there are. So for the second problem that's asking for 132 cups is equal to how many gallons and cups. We don't have to work out the problem again, okay? But the answer is going to be 8 gallons and 4 cups. So what we know is that when we start off with cups, the remainder is going to be in that same unit that we started with. Since we started with cups, that's going to be a remainder of 4 cups. Alright, so that concludes our notes for tonight. Go ahead and complete the practice problems on Moodle. When you finish that, rate yourself on our scale and write that at the top of your notes next to the heading. If you have any questions, please bring them to class tomorrow, and I'll be more than happy to answer them. Have a good night.